Alright, Tony, back for the fifth video. This is a long chain of videos. Anyway, let's get into the inputable system, or the keyboard input system. Right. So we've got the basic, or well, I shouldn't say basic, but the starting line here, which is the inputable class. Inputable attorney, of course, does actually quite a few things. It communicates to the two different managers it has, because of course it has two managers. And of course registers for registration with the scene. Yeah, it's got a little class here, the event type. Actually, come to think of it, the event type should be used less, and that was, I believe, something that you told me to fix, and I never got around to fixing it. Sorry about that. So be prepared for more checks than there probably should be. Yes, but it all works, so, hopefully not too bad. And it is only checking a few extra times per key registration, which is not that much compared to like it checking every frame. But I'm sure points are being deducted right now. Anyway, uh, yeah. So I believe we've looked at Big Four. Yeah. Of course, this is functions for the user to call, and yes, here's our blob of data to with our two references, our two commands for save, and then our current registered state. Right. Anyway, inputable. I believe these are right. So we have inputable, key registration, and is a lot of code. Let's try not to go too in depth here. Actually, that shouldn't be there. Anyway, yeah. So we go through the again checks that probably shouldn't be there, but I honestly I gave it a try to figure out how to do it, but I couldn't really figure out how you would eliminate the checks. Like, I understand that you could put the um, event type in the pair, but once I got down to look at it, I was like, but then how do you check? Because you still have to search through the map, and you can only search for one key, I think, right? So anyway, it's a thing. We got our registration, our other layers of registration, and then the different setters and getters for the references. Right. So that should be it for the inputable parts. Let's look at the copious amount of managers for the input system. Let's start with the single key manager, and then head on to the keyboard manager. Right, so here we are. Actually, I can uncomment these, and we can see that they get destroyed. I guess I've really already shown that they get destroyed anyway, but let's just show it off anyway. Probably should stick that one in the other. Right. And yes, I don't know why it's being destroyed multiple times, but it's being destroyed. That's for sure. Could it be calling that? Either way, it's being destroyed. Right. So anyway, let's get to the actually working parts, or the actual code parts, I should say, rather than debug stuff. We've got this is the process event that's called by the scene. No, don't move that. which checks each key, of course, every frame for the and then notifies all the observer classes of their requested keys, which is requested by registering, which is part of the long indirection process to register to them. Right. And then the keyboard manager, which is one level above the single key manager, which this manages the single key managers. It's so complicated. This was a fun week, not gonna lie. Probably the hardest one for me, just because there's so many layers of indirection. Anyway, here's its process events function, and then it's got its register and deregister, and of course it cleans up its things because it actually manages the keyboard managers, unlike the keyboard managers, which just have pointers to things that it doesn't actually manage, so it shouldn't delete them. Or actually, that's still key event manager, but yeah, you know what I'm talking about. This one. Yeah, that's why one has a yeah. So let's make sure this is called. Should be being called. And why does it have to rebuild every time? Don't understand. Why you do this to me, Visual Studio? Try and make a video. Right, there we go. But well, this is calling it for the null scene, technically, which ends up getting deleted when you change to the first scene. Yeah, anyway. And we're still on that practice scene, which we shouldn't be because it's boring and makes eyes bleed from sadness. Anyway, that's probably why it's rebuilding stuff. But should I have already rebuilt all that stuff? I don't know. Either way, Visual Studio works in mysterious ways. If there's anything I've learned in the last year or so is that Visual Studio works in mysterious ways. Anyway, that should be it. Actually, there's some commands that we should look at. How am I doing? Not too bad. Not too bad. Where are the commands at? Register system, of course. Where else would they be? So these are slightly more. They carry some more things, partially because I have those extra ifs that I couldn't figure out how to get rid of. Guess I'm just not smart enough. Oh well. Right. So deregister. Again, nothing too out of the ordinary there. All the commands are pretty much the same for the most part, except for maybe the collision commands, which actually collision's next, isn't it? I don't think I have any documentation for input system. Sorry. Destructor, we did that. Process, not entirely efficiently, but at least I have the recycling of the commands and whatnot, and the constant time deletion. Just a few extra ifs in there on register, which is, not ideal, but not the worst thing either. Prevent duplication efficiently. Yes, yes, yes. Oh yeah, it breaks if you try to do multiple commands. I guess I could show that in a second here. Done using command pattern? Yes, I don't know how else you would do it. Be incredibly difficult to do it any other way. And the associated full header report. Yes. I don't have a class diagram of it, unfortunately. Although that would probably be super helpful. Now that I think about it. Probably should have made one of those before actually trying to build it in the first place. Anyway, what was I going to do? Yes, I was going to build and all that. Here's a thing that has inputs. Player, obviously. So let's just do two of the same one and watch as it explodes, because that's important to prove. And also, watching things explode is fun. Yay, it exploded. Good job. Good job, me, at exploding my own program. Of course, if I run it without that extra copied line of the same thing, it does the normal thing, which actually I like how my demo looks, even if it's not what you'd like. I'm still pretty happy with it and proud of it, to be honest. But whatever. Ooh. Right, so I believe that's inputs done. Not as fast as I would like, but such is life. Collision system. Yeah, let's go through collision system and then I'll break it off there. I don't want to spend even though the input system is massive, I would like to get at least 2 systems done per video. I think that's right. So we got collidable here, small blurb peroxygen, and friend class attorney. Right. So this is for the registering of the commands, similar to the other examples. Yay has a big 4 with a virtual destructor. Double yay. Right. So it's got vSphere. This is for the visualizer, which I probably need to take a look at next. Yeah, the collision function defined by user, virtual of course, and then the little set collider group function, which has been naughty lately, but it works. It's just that it happens to be telling me that something else works, and it makes me angry currently. The scene change anyway. Bear the bad news. Anyway, got its protected functions for the user to use, and yeah, these are the functions used for the setting up the collider model and the update the thing. Yep, just all the things here to make things run smoothly. Let's look at that code for initializer list and the standard setup that I'm sure everyone loves seeing, the registration system. And then we've got setting up vSphere for the visualizer and the set collider model, and yeah, that's for more using the collision system. Anyway, that's that and that. So that's collidable. Let's quickly get managers and the rest of the system, and then I'll call it. Right. Oh, I forgot how many classes this has. Yeah, I think we'll take a decent time regardless. Anyway, collision manager. Right. So this has some more of those pesky templates to send the dispatches, and of course have the unique ID numbers for each class type, or each class, like bullets or tanks, well, enemy tanks or player tanks, has their own group so that they can be collidable. They can be checked against the ones that the things that they collide against as a group every frame. Right, so that's process function here. I set the max collision group to 64 because I don't see anyone ever getting to that. I hope so, anyway. Fingers crossed. And because it's a nice multiple of 2, you know? It's one of those multiples. Good. I figure it's good. It's high enough. Good. Oh, I'm going insane. Anyway, we've got our destructor here. Let's make sure it does its destructy thing. It does. Let's make sure it does it at the proper time. Yes, it does. Whoa, look at that. It's getting rid of things. Cleaning things up real nice. Anyway, excitement aside, let's get on with business. So, returning the or this is returning the proper group based on your ID, like the group of bullets, for example, so that it can get the proper groups for the two things that it wants to test, if it's a pair function or pair collision test, or self, it'll just be the one. Yeah, anyway, you know how that goes. Got its process collisions function here, which is called by the scene. Refer to the second video. Leave that in case you wish to see it. Well, I suppose I could just pull up scene. Why not? But yeah, refresher. We've got all the things are doing the things. Anyway, collidable group. Yes, so this is class that holds the collidable pointers, or the pointers to the collidables, so that it can give out the proper group, or it's the class that's given out with essentially sorry, I'm blanking here, to yeah, for the have the group of the thing that's being collided against, the two different groups. Yes, anyway. Oh, I don't know why that was so hard. Yeah, anyway. So it's pretty bare bones. It's got its constant time erase function. Those are pretty proud of making all those work. Mostly because it was problems were encountered, problems were dispatched. Speaking of dispatches, we've got our dispatches. Or no, these are actually test commands. Anyway, this is the self collision test. Not very often used, but it does test against this part's the visualizer. Yeah, it does test against itself. Just the one collection group. Collidable group collection. Right, so pair test function, the more commonly used call or collision type, at least in any game that I've ever written or been a part of. Right, so it's got two groups, which it checks against each other, one at a time, goes through them in a relatively efficient manner, and not duplicating, because smart math. Yeah, anyway, you can check that if you so desire. And this is just a base class here for the commands. These commands. I generally like to use the same base command with just an execute in it for everything, all commands. But this was a special case. It had to have its own base class. Or it made more sense for it to have its own base class anyway. I guess it didn't really have to. Yeah. Anyway. Got our dispatches here, which are template related. Got the wrapper base, so that you can kind of get this was, of course, this was your idea, but yeah, it was to get around the templates, so you don't have to propagate templates everywhere, which is great. I appreciate it very much. Thank you. Because my not little, but my small experience with templates in this class has been not favorable. Anyway, we've got process callbacks here on this is what calls the two different user-defined functions. It comes from, I believe, Collision Manager. No, it comes from the test command. Yes, it's been a while since I've looked at this. Yeah, anyway, here it is, calling them pdispatch on the two. Yeah, so that's the convoluted collision system. Well, I suppose not really convoluted, but here's the B-spheres, B-sphere classes, collision volume class is used for the visualizer, which this video is going to be almost, it's 20 minutes already. Oh my gosh, I've done bad things. Right, let's take a quick look at the visualizer and I'll chop it off here. So, got the two commands here. Visualizer itself. The singleton, it's got its own attorney, and of course it has a few things here to run through the commands, which are then processed and creates the visual wireframe sphere, which it uses a singular model for and just basically teleports it around. Right? Suppose just renders it in multiple locations every frame. I believe is how it works. I don't know. I'm not really familiar with the guts, but pretty sure that's how that works based on my experience in this class and rendering and graphics. Yeah. So here's the visualizer attorney. Crazy as well. It uh, synergizes with the game class. That's what that is. My main game class. And then of course with the B-sphere commands. Right. So fun times are had all around. I'm gonna cut it off here. See you in the next one.